Hello all, this is C for Embedded Systems. Please subscribe to the channel for more such videos. In this video, let's learn more about arrays in C. What is an array? An array is a fixed number of data items that are all of the same type. The data items in the array are referred to as elements. Elements in an array are all of type int or of type long, all of any type you choose. So what it means is that array can hold a fixed number of data items that are of the same type. So how do you declare an array in C? The array declaration is similar to declaring any normal variable that contains a single value, except that you have placed a number, that is the array size, between the square brackets following the name. So you can see that the way the syntax is, you have to mention the data type, the array name, and followed by the array name, you should place square brackets. Inside that, you have to mention the array size. The data type is uh, the data type of elements that the array will hold. That's the data type. And then array name is basically the name of the array. The array size is the number of elements in the array. It must be a constant expression. It's literal or a defined constant. These are the things that should be array size. So here is an example. Long numbers within the bracket, we have mentioned 10. So here you have numbers, array of numbers, which are of type long, and they contain 10 elements. That is the understanding. Then how do you access this array? So each of the data items stored in an array is accessed by the same name. So in the previous statement, the array name is the numbers. So you select a particular element by using index value, so between square brackets following by the name. Index values are sequential integers that start from 0, and 0 is the index value of the first array element. The index values for the elements in the numbers array above run from 0 to 9. So the index value 0 refers to the first element and the index value 9 refers to the last element. Therefore, you access the elements in the number array as numbers within the square brackets 0, numbers within square brackets 1, and numbers within the square brackets 2, and so on, up to the number within square brackets 9. So you can see same in the below figure. So in the figure, you can see that you have an array declaration called long numbers of with contains 10 elements. Then the first element is number 0, second element is number 1, third element is number 2, and so on. The 10th element, the last one, is number 9. So you can see that you do that with the number, it's an array name, and then the index value has to be mentioned. So you can specify an array index. Uh, you can specify an index for an array element by expression in the square brackets following the array name. So one important thing is that the expression must result in an integer value that corresponds to one of the possible index values. So say for example you have numbers within square brackets, you have to mention an expression. So this expression should result in a number. That's the understanding. So when you use an expression, the only constraints are that it must produce an integer result, and the result must be a legal index value for the array. So that's the only constraint. So it should result in an integer, and the result must be a legal index value. So in the above case, for example, you should have the numbers and it should be within 0 to 9, the index value. Well, let's see an example of this. In this example, what we do is we read the value in the array and then add the array elements and calculate average and print the result. This is what's going to be in this example. So let's see that. I have a file called array underscore average.c. In this, we have defined or included. So in this, we have included stdio.h, and inside main, we have declared array to store 10 values. So int grade within the square brackets, we mentioned the size is 10. So that it means is that the grades is an array of integer which holds 10 values of integer. Then we have defined unsigned int count. This is basically the number of values to be read. Then the long sum to hold the sum of the numbers. Then floating number average, which we have initialized to 0, average of numbers. And in the for loop, we basically take the grades, the numbers, and then we, as and when we read it, we add it to the sum. Then average equal to, we just calculate the float sum divided by count, calculate the average, and we print the average. So let's execute this and see what happens. GCC, let's first compile this. GCC array average.c, and then we execute it. It says enter the 10 grades. So I'll just enter the grades. So out of 10, for example, you have 8, 9, 6, 7, 8, 9, 8, 9, and then the last element is 9. Okay, so the average of the 10 grades entered is 8. So what you would understand is in this program, we have declared the array, or declared and defined the array, and then we read the values and then get this, we compute the sum and then compute the average, and we print it. So I hope this is clear. Well, okay, in the previous example, what we saw is we read the array elements when the program is executing. So let's see, how do we initialize an array? So in many cases, uh, mainly in embedded systems, you would have to initialize the array sometimes. So how do we do that? So to initialize the elements of an array, you just specify the list of initial values between braces and separate them by commas. So the declaration looks like you have a double values of 5. You have 1.5, 2.5, 3.5, 4.5, and 5.5. These are the values separated by comma and then should be within the braces, and you end with the semicolon. So that's how you initialize the value. So this declares a values array with 5 elements. Elements are initialized with the value 0 having value 1.5, value 1 having initial value 2.5, and so on. So to initialize the whole array, there must be one value for each element. If there are fewer initializing values than elements, the elements without initializing values will be set to 0. Thus, if you write a double value 5, which is equal to initialize with 1.5, 2.5, 3.5, only the first three elements will be assigned with the actual values that you have passed within the braces. The rest will be assigned with 0, 0.0 in this case because it's a floating value. So I hope this is clear. The first three elements will be initialized with the values between the braces, and the last two elements will be initialized with 0. So knowing that, the compiler will supply zeros for elements for which you don't provide an initial value, offers an easy way to initialize an entire array to 0. So you just need to supply one element with the value of 0. So the easiest way to initialize the whole array is just declare the array and initialize it like double the values 5 and just give one element with 0.0 and the rest will be assigned with 0.0. So if you put more initializing values than there are array elements, you will get an error. The message from the compiler, however, you can omit the size of the array when you specify a list of initial values. So in this case, the compiler will assume that the number of elements is the number of values in the list. So when you declare or when you define an array like this, int primes within the braces, don't put anything, let it be empty, and then you initialize the array. So compiler will calculate the size of the array and then uh, and it assumes not assumes and it assigns the, the primes with the size of this array. So the size of the array is determined by the number of initial values in the list. So the primes array will have 10 elements. So that's the understanding. So let's understand this with an example here. So we have a file called array init.c file where we have demonstrated different ways of initializing an array. So the first use case is that initializing an array of integers at the time of declaration. So we uh, initialize like int numbers 1 within braces 5, which is equal to 1, 2, 3, 4, 5. We separated them by commas and end with a semicolon. Next is that initializing an array of integers with 0. So as we saw, int numbers, int array of 5 numbers is equal to 0 within the brace, and it will initialize everything to 0. Then initializing an array of characters at the time of declaration. Okay, so here I missed to provide semi or single quotes because without single quotes it becomes characters. Let's see what happens. I think it will result in an error or so. Let's see what happens. So ideally, then 0 was 1 0 is not a character, it is a string. So let's see what happens. GCC array init, you see that it throws an error. Sorry, it throws basically a warning saying that this is overflow in implicit constant conversion. So what I do is that I'll roll back. I will make it array of integers to get the values here. Okay, fine. So let's compile this. GCC array init, then a.exe, we execute it, and we see that number one is 1, 2, 3, 4, 5, number two is 0, 0, number three is whatever the values that we have assigned. So here you can see that the numbers in the third case, line number 11, we did not pass any value between the braces, between these square brackets, but the compiler reduced its size. Okay, so this is one use case wherein if you do not provide, let's say, enough elements inside the brackets, it has to assign the rest with the zeros. So you can see that it is assigned for array number 1, array 1, it assigned last two elements with 0. And say for example, you provide one more value to numbers. So that means you initialize array 1 with 6 elements and see what happens. You see that it gave a warning. Ideally, this is not correct. And execute it and it prints, but it throws it throws a warning. Okay, so that's about initializing the array. Let's look at one of the major cause for a lot of issues in C is that uh, out of bound access. So this is this needs to be addressed. Well, you must know what is out of bound access and how to avoid out of bound access. So know that if you see an expression of index values that outside the legal range of the array, the program won't work properly. The compiler can't check for this, so your program will still compile. So you'll pick up a junk value from somewhere so that the results are incorrect and may lead to runtime errors. So these are very subtle bugs which are very difficult to debug. So it is therefore important to ensure that your array indexes are always within bounds. So here's an example to illustrate an array out of bound access. Let's see this. So let's copy this file name, search here. So we have a file name called array out of bound access. So what we did is int numbers 5 and initialize with the 5 elements, 10, 20, 30, 40, and 50, and attempt to access an element outside the value range. So the value is the number within braces. You mentioned 6. So here the numbers is of size uh, 5, and then we want to access the sixth element. So let's compile this and see what happens. GCC array out of bound access, then here at exe. See, the compiler even did not throw any error. So ideally, is as a programmer, you you would miss it. So that's the uh, and you see that instead of so because you access the sixth element, the value at the index 6 is a junk value, which you don't know what it means. And let's say if you choose this in the further computations, your you're bound to have errors, very subtle errors. Well, compilation time, you did not find it. During runtime, you would face it. And it's difficult in large programs. It's very difficult to debug. And that is about the out of bound access. One thing you have to take care is that uh, so the C provides a size of operator. So whenever you want to access this, the maximum index has to be of the size of the array. So take care so that you don't end up having a lot of issues at runtime. So, well, that's all for this video. So we learned about arrays. This is the first part, and we will have a part 2 next. So thanks for watching.
Subscribe to the channel for more projects, courses, tutorials, and tools.